So one of the really surprising things about general relativity is that if you're sitting still and something moves by you, it's going to appear to be smaller than if it was just standing still. So if we had a cube like this and we could identify the sides, so it wasn't just, just this tracing out this rectangle, but you could actually see it in snapshots.
Okay.
Maybe the orange looks best, I don't really know. And it was just sitting here and it was kind of this wide.
Okay.
If it went whizzing by at nearly the speed of light, it would actually appear to be shorter.
Interesting.
It would shrink as it was moving. So, and it's moving in this direction. So only in this direction does it shrink. So you would still see it to be the same height.
Just kind of get thinner.
Yeah, you would see it compressed. And that actually leads to some strange paradoxes. Because if you had some gates here, let me draw them in like this, and I asked you, hey, does that cube fit inside of those gates? And I just put it down there? You would say?
No, it doesn't.
No. But if it went whizzing by at nearly the speed of light, I asked you, hey, was the cube ever inside of those gates?
Then it would be.
Then it would be.
Yeah.
So does that seem strange to you?
Yeah.
Can you tell me a strange consequence that that might produce that doesn't seem to make any sense at all?
Well, I mean, if you somehow threw it at a really high speed, and then it sort of was at an angle where it would go through the gate, and then it went through the gate, and then on the other side it would stop, and then you'd see that no matter how you would do it, you can't really fit through the gate.
Oh yeah, that's a great point. You could somehow, it could somehow shrink to maybe go through something that it wouldn't be able to go through previously. Yeah, and that gets complicated by the fact that it only shrinks in the direction that it's moving. But we could modify that. There's actually a famous idea about a car driving into a barn. You want to hide a car, this is your car, and those gates are your barn, and you want to hide the car in the barn. The problem is the car is longer than the barn. So what you do is just send it into the barn super fast, and then when it's inside, you close the two doors. So what do you think happens then?
Well, either like the car will like break out the sides, or the barn will like hold it.
Yeah. So that's definitely one surprising thing. And there are lots of other surprising things in relativity. And actually, something that you've been starting to study a little bit tells you how much it shrinks. There's just an equation that I'll just write down. I'm not going to really talk too much about what it means. But it's the square root of 1 minus v squared over c squared. And that can tell you how much things are shrinking by if you can measure this quantity. But this quantity is not actually super hard to measure because the only thing that's changing is your velocity, how fast the things... the velocity.
Oh, yeah, velocity.
Velocity, not volume, yeah, velocity. So if it's moving, let's say it's moving at half the speed of light, just for example.
Alright.
Okay. And the speed of light is approximately 186,000 miles per hour.
Okay.
So that's a lot, that's pretty fast.
Yep.
But if it's moving at like 93,000 miles per hour, half that, what is v squared over c squared going to be if v is half the speed of light? What's v squared over c squared going to be?
It's going to be... Isn't it about 1/4?
Yeah, it'll be 1/4.
1/4.
So if you're moving at half the speed of light, it's going to shrink 1 minus v squared over c squared, 1 minus 1/4. What's 1 minus 1/4?
It's 3/4, so square root of 3/4.
Okay, and what is the square root of 3/4?
Root 3 over 2.
Root 3 over 2. And do you happen to know what this is, approximately?
Don't. Well, root 3 is like somewhere between 1 and 2. It's gonna be a little bit like maybe 1.7, I think.
Yeah, it's about 1.7.
So it would be 0.85.
Yeah. So So if something's moving at half the speed of light, it's shrunk by about 15%.
Okay. That's cool.
So, yeah. But that's hard to measure, and it's particularly hard to measure because, do you know how fast like a car drives on a highway?
60, 70 miles an hour.
Yeah.
So yeah, you can't.
So the car is not shrinking very much in that scenario.
Yeah.
Yeah. So, but we could calculate that if we wanted to. But let's go and look at these programs that talk about what the cube actually looks like when it's moving.
Okay.
All right?
Yep.